Hello, Math 20s. This is going to be the last lesson for the statistics unit. It's called confidence intervals, which you'll see there's a page that looks like this. But what I wanted to do just for a little bit before is just in almost the back of your book, it's the second last page before the big chart, the Z-score chart. There are a couple of problems in there, and I just wanted to go over a few, just since we didn't really specifically touch on them when we were looking at the standard normal distributions and calculating Z-scores last day. So I just wanted to peek at a couple. So I just cut this right out of your notes package. So there are 8 questions, I believe. Not a lot of room to do them, and then actually in your notes package the answers are below. So you'll probably want to do these on just for practice, do them just on scrap paper because there's not enough room really to fit it very well on there. But I wanted to look at some specifically that are a little bit more complex than the questions we were doing in class, or not more complex, but just a little bit of a different way of thinking. So number one is pretty straightforward. You can figure that one out. It says for number two, a university test was given where the scores are normally distributed. A student had a score of 63%, which was 2.13 standard deviations above the mean. If the mean of the exam was 57%, then what is the standard deviation to the nearest hundredth? So I don't really have room to write on here. Oops. Let's full screen this. Okay, so just looking at question 2 there, I'm going to write up above because I don't really have room. So we're given a couple pieces of information. So we're given the student score. So the student score was 63%. We're giving the mean as 57%. And we're given how many standard deviations above the mean the student score is. So remember yesterday, I said that 2.13 standard deviations above the mean is actually equal to the Z-score. So we know the Z-score is equal to 2.13. So it's a little bit more than 2 standard deviations above the mean. We know the mean, so either is x bar or mu, is equal to, 57%. And his raw score, so if we're thinking in terms of the Z-score formula, that just represents x because that's his data point, is 63%. And it's asking us for the standard deviation. So that formula, just if you're in your booklet, remember you can flip over and just above the really big chart, there is a formula that says Z equals x minus mu, which is your mean there, divided by standard deviation. So what we're actually looking for in this question is we are looking for our standard deviation. We're trying to solve, oops, what have I done? We are trying to solve for the standard deviation. So we need to rearrange that formula to solve for the standard deviation. So just like in other problems, if what we're solving for is in the denominator, it's a little bit of a problem. We need to do our two-step process to rearrange to solve for our standard deviation. So we know right now I have the raw score minus the mean divided by standard deviation. So I'm going to multiply both sides by standard deviation. What you do to one side of the equation, you have to do to the other. So now I have my Z-score multiplied by standard deviation equals x minus the mean. So now what I need to do is divide both sides by the Z-score. So this gives me a formula of standard deviation is equal to the raw score minus the mean divided by the Z-score. So you can see that we can use that formula in different ways. We used it last day to calculate out the Z-score, but if we have those other pieces of information, we can actually calculate out standard deviation. Or I could, if I gave you the Z-score and standard deviation, and maybe the mean, I could get, or you could rearrange to solve for the raw score or your data point, whatever you want to call it. So that formula can be rearranged depending on what pieces of information you're given. And that's why I wanted to go over this, because I think a couple of these have that rearrangement as a requirement. So for this question, you'd go 63 was his score, subtract the mean is 57, divided by standard deviation is 2.13, gets me, or sorry, divided by the z-score of 2.13, gets me a standard deviation of 2.817, something like that. So the standard deviation for it, no, yeah, the standard deviation for it was 2.817. I'm just going to pause because Alana's looking at me right now. I'm recording a lesson, Lana. Hang on, guys. Alana was confused why I was teaching right now because I'm supposed to be on prep. But I'm recording my lessons for you guys. Okay, so that's question 2. So again, you can rearrange that formula to solve for something different, so to solve for the standard deviation. Um, okay, let me just see which other one. I'm gonna do number 5, I think. Yeah. So there are some that are a little bit harder even than the 2 that I'm doing here. So I want you to look through it and think about what pieces of information you are, actually no. Let's do number 6. I want to do number 6 instead. So number 6, so it says a lawnmower company knows the average life of lower mowers, so the lawnmowers that they're selling, is 9.3 years, and the standard deviation is 2.2 years. The company does not want to replace more than 6 out of the 200 lawnmowers it expects to sell. What guarantee to the nearest tenth of a year should the company provide in order to satisfy its replacement policy? So they put a warranty on the lawnmowers. If it breaks down in 2 years or something like that, we'll replace it for free or something like that. But you want a solid enough warranty that kind of drives people to purchase, right? That they're like, oh yeah, that's a good warranty. If something happens in the first couple of years, I'm not going to have to replace it right away. But companies also don't want to be replacing a ton of lawnmowers, right? If you make the warranty too long, then they're going to be replacing everything if everything breaks down. So for this one, I'm just going to scroll down. Let me, okay. So we're given a couple pieces of information again. So thinking about what we have, we have the average lifespan. So that is representing the mean is 9.3 years. The standard deviation is 2.2 years. And that's really the only numbers we're given, but we're actually given information that we can pull out of. So they don't want to replace more than, I guess I can't go up much more than that. They don't want to replace more than 6 out of 200 lawnmowers. So they have 200 of these lawnmowers. They don't want to replace more than 6 out of the 200 that they expect to sell. So what that represents is they don't want to replace more than 0.03 as a proportion, which is 3% of the lawnmowers. 6 divided by 200, then multiplied by 100 is 3% of the lawnmowers. So 0.03, what that actually represents is, if we lightly sketch out our curve, again, this is our mean of 9.3, our standard deviations are 2.2. I'm not going to write all that in, but they don't want to replace more than, like this is the tail end, so whatever, that's 5 years or something like that. They don't want to replace more than 3%. So they don't want to be replacing 50% of the lawnmowers. They don't want to be replacing 20% of the lawnmowers. They want to replace only 3%, the ones that have like the worst battery life or whatever it would be, I guess the engine of it. Sorry, I'm drinking my tea while I'm teaching here. So 3%, what that represents is the area under the curve. And now I realize that I don't have the big chart anywhere. So let's zoom to this. It's going to have to be sideways. I guess there's probably a way to turn it. I'm not going to fight with it right now. Oh, here we go. Rotate. Okay, so what we want is we want an area under the curve that corresponds to that 0.03. So we know that it's going to be, again, on this side. So it's going to be a negative number of standard deviation. So it's going to be below the mean. If you try to look over here, these are all big numbers, 97, 64%. So we're looking for 0.03. So peeking around, it's kind of somewhere around here, right? We don't get the exact number, but we're pretty darn close. So I'm going to estimate it at negative 1.88. It's probably slightly more than that, 1.885, something like that. But we're just going to use that 1.88. So that represented, again, the area under the curve. So that gives us a z-score of negative 1.88. And so now what we have, if we look at that equation with our z-scores, so z equals x minus mu over standard deviation, we have the z-score, we have the mean, we have the standard deviation. So what we're actually looking for is that raw data point that gives us 3% of the curve to the left of it. So we need to rearrange that formula to solve for just that raw data point, to solve for x. So I know to rearrange that formula, I need to multiply both sides by the standard deviation. And then to get x by itself, I need to add the mean to both sides. So now I have z multiplied by the standard deviation plus the mean is equal to x. So this is the formula that we can use. Make sure you know how to rearrange for any of those things within the formula. And so now I can substitute the values in. So z was equal to that negative 1.88. The standard deviation was equal to 2.2, I believe. And the mean was 9.3. And so if you punch that all in, I believe we get 5.16 something like that years. So just kind of relating it back up to the question is, so, guaranteed to the nearest tenth of a year, so I guess it would be 5.2. You see in the answers it actually says 5.1. I think maybe they used a different z-score. They might have used negative 1.885 or something like that to get a little bit of a different z-score. So nearest tenth of a year should the company provide. So again, just looking at this little bad chart that I made. So we know one standard deviation below the mean would be 7.1, and you could figure out the rest. This point right here is negative 1.88, and that gives us 3% below the mean. Sorry, in terms of z-scores, it's negative 1.88. That gives us 5.2 years is kind of the amount that they would need to make it to not have to repair more than 3%. It would be weird, though, as a manufacturer to say our warranty is 5.2 years. So they'd probably actually say 5 years because that's going to be even less than 3%. But still a pretty good warranty, I guess. So I would definitely recommend doing all of those questions and then comparing with those answers at the bottom, thinking about how you can rearrange what pieces of information you are given. So now on to today's lesson. It's pretty short, actually. So confidence intervals. So a confidence interval is a range in which a polled or surveyed value is predicted to be true. So you see this a lot, like heading into elections, they'll be polling things, and you'll actually see confidence intervals if you're watching like some, not just the regular news, like some business news or something like that. But you also see it with other pieces of information when they'll say like 84% of Canadians support this, something like that. So what they've done at some point is either done a phone survey or some other type of survey through some type of media outlet. And they've asked questions and they've taken the information that they get from the respondents and they're trying to look at, is it reflective of the population, right? If you just do a survey outside of, I'm trying to think of like a rich store, let's say Tiffany's, the place that sells diamonds and rings and stuff, about if you do a survey outside of Tiffany's and you're just getting rich people that want really big diamonds, that might not be reflective of your entire population. So you want polls to be wide ranging for individuals that they are surveying so that it's more reflective of the general population. So the way that the confidence interval is usually written is x plus or minus. You guys have seen this plus or minus before when we did the quadratic formula. So it's saying x, like a value plus or minus the margin of error, where the margin of error is expressed as a percent. A confidence interval is used to make predictions about a population based on samples of the population. So we have confidence interval and we have confidence level. So the confidence level is the probability that a value falls within a specified range of values of the confidence interval. So the confidence interval is affected by the margin of error and the sample size. If the sample size stays the same, so if you're sampling the same number of people, the margin of error increases as the confidence level increases. And if the confidence level stays the same, the margin of error, sorry, I should be writing that down. So the margin of error increases as the confidence level increases. And if the confidence level stays the same, the margin of error decreases as the sample size increases. That isn't as important. I think you guys see one question somewhere. Maybe it's in the statistics assignment that brings that in. So we'll look at just, I think, 2 questions here. So it says a telephone survey of 500 randomly selected people was conducted. The survey determined that 35% of Canadians from 24 to 45 years of age have an electronic book reader, so like a Kindle or a Kobo or I guess like an iPad where you can read books on, the results are accurate within plus or minus 5 percentage points, 19 times out of 20. Um, so the number of people in this age range were approximately 8.7 million people at this time. It is assumed that ages are normally distributed. They're not really normally distributed, but that's okay. Um, so what this is kind of saying is so the survey was done, but if we randomly called, let's say 100 people, so we just dialed random numbers from the phone book and we asked if they were in that age range of 24 to 45 years old. And then if we asked if they fall in that age range, if we asked if they have an electronic book reader, if we did that 20 times, so we called 100 people 20 different times, 19 out of the 20 times, we would get a value between 30 and 40. So that is related to that percentage of 35% plus or minus 5 points. So there's lots of numbers there. That's the big thing. But it's saying if we randomly called a set number of people, so let's just say 100 people, and we did that 20 separate times. So in total, we would be calling 2,000 people, but if we did it in little groups of 100, 19 of the 20 times, we would expect that the number of people that have had an electronic book reader would be between 30 and 40. So sometimes you might just have 30, sometimes you might have 35, sometimes you might have 40. And then probably one time we'd have a set that wasn't in that range. So maybe one time we would call and we'd only get 25 people that have an electronic book reader. So this is what this whole section is about, is these confidence intervals and confidence levels. So a couple of questions that pop up there. So what range of people own an electronic book reader? So it's asking for the range here. So the confidence interval, I've already kind of talked about most of this. Confidence interval was 35% plus or minus 5%. So 35 minus 5% is 30. 35 plus 5% is 30 to 40% of people in that age range. So the range would be 30 to 40%. Determine the certainty of the results. How certain do we feel that these results are accurate? And so that comes from that confidence level. So since it's saying it's accurate, 19 times out of 20, again, that's our confidence level. So we could do 19 divided by 20 multiplied by 100. We're 95% certain of those results. And finally, it says, how many people in Canada between 24 and 45 would you expect to own an electronic book reader based on this survey's results? So it gives us that in that age range, there were about 8.7 million people. So we think that it's between 30 and 40% of it. So if we multiply this by 0.30, representing 30%, and we multiply it by 0.40, representing 40%, we'll get the range of how many adults we would expect again, from that age range of 24 to 45, how many we would expect to have it overall. So multiplied by 30 is 2.61 million. And multiplying it by 0.4 is 3.48 million. So the way that we can kind of express that, we could just give that range. I'm going to write it out as a little bit of a sentence. So it can be said with 95% confidence between 2.61 million and, oops, I forgot a zero there, 3.48 million Canadians from ages 24 to 45. Sorry, there should be an R there. It doesn't really look like it. From 24 to 45 years old. Have an e-reader. It's an electronic book reader of some sort. So again, they just do these little surveys because it would be pretty much impossible to call all those 8.7 million Canadians to get the specific number of how many people have an e-reader. So they just take little samples to get ideas about what the overall population would actually look like. Again, you probably don't want to be doing this survey just at the Apple store in front of the iPads or something like that, or at chapters where people love books and they probably want multiple ways. So you want to have a survey that is hopefully giving an accurate representation of the population. All right, one more, and then I'm tired. So the last question here, it says a 2010 poll determined that 65% of people agreed that wind power should be used over hydropower. So using wind power over power generated by the movement of water. The results of the survey are accurate within plus or minus 2.9 percent points, 19 times out of 20. So it's asking us a couple different things. So state the confidence level, the confidence interval, and then it's asking how many people, the range of people that believe this. So confidence level, again, you want a pretty high confidence level. If you're saying we're only 5% confident in this data, well, that's not very confident. That means that your survey was not going that well. You don't have an accurate survey. You're not polling the right people. So the confidence level, again, it's saying it's accurate 19 times out of 20, which is the same confidence level as last time. So it's a 95% confidence level. The confidence interval, so 65 plus or minus 2.9%. So to get that range or the interval, so we're going to subtract 2.9 from 65, gets us 62.1%. And we're going to add 2.9, that gets us 67.9%. So this is our confidence interval. So between 62.1 and 67.9% of people agreed that wind power should be used over hydropower. So in 2010, the population of Nunavut was 33,220. State the range of the number of Nunavut residents who would have agreed that wind power should be used over hydropower for generating electricity. So again, what we want to do is use our confidence interval. Let me scroll up. We want to use our confidence interval to figure out how many people that actually represents. So our population, 33,220. and we're going to multiply it by both of those percentages as a proportion. So multiply by 0.621 and multiply by 0.679. So that gives me 20,630, and this one gives me 22,556. So that range of 20,630 to 22,556 would agree. I guess Nunavut residents, but not vit, but now it looks like a W. Nunavut residents would agree. And then you can kind of write out the end of that sentence, would agree that wind power should be used over hydropower for electricity generation. Okay, so my darlings, what you should be working on today is probably those application questions that I have at the beginning here. So those application questions from that standard normal stuff. There's no confidence interval questions in your notes package here, as you see. So you'll need to go to the textbook to look for some of those. I would also do the textbook questions, the review textbook questions. Oh, sorry, I don't have it. I think it's probably page 302, maybe a little bit later than that. And then once you've done those, so again, do the textbook practice questions because you can check your answers and kind of make sure you're on the right track. On Monday, you have a work period, I believe. I don't have my schedule in front of me. A work period to work on the statistics assignment that should be in your package that you guys have. So that's what your Monday can look like. So for today and over the weekend, I would finish up any questions that you didn't do in the booklet or any of the textbook practice questions. And then on Monday, work on that statistics review assignment and get it to me kind of end of day Monday. I can get it marked for you if you get it to me quick. So you can have those results before your quiz that's on Tuesday, I believe. I'll have to double check that. So that's what you guys are working on, and have a great day.